Good afternoon, everyone, and welcome to the webinar. My name is Connor Houghton. I'm an account manager here with CAD Micro, and joining me today is our digital manufacturing technical manager, Kirsten Waters.
Hey, Connor. Hey, everyone.
Hey, how's it going, Kirsten?
Good, good. Good to see you.
So thank you, everyone, for taking the time to join us today. A few housekeeping notes before we get started. Throughout the presentation, please feel free to type any questions in the question box on the right in the GoToWebinar panel. We will be taking the time at the end of the webinar for a Q&A period. We'll have an account manager or technical expert reach out if any of your questions don't get answered during that session. This webinar is being recorded, so if you have any colleagues that weren't able to make it today, you will receive a copy at some point tomorrow. Kirsten and I wanted to break the mold a little bit with your typical webinar by painting a bit of a customer scenario for you guys. Forgive us beforehand for the subpar acting chops, but essentially with the webinar today, we want to be covering four main topics throughout the presentation, those being the difference between SOLIDWORKS CAM and CAMWorks, as well as some key functionality in those packages, automatic feature recognition, the built-in automation and technical database, and finally, CAMWorks shop floor. So Kirsten, if you're ready, do you want to jump right in here?
Sure, yeah. So just a quick note, apologies for the renovation going on behind me. That work from home life, am I right?
Exactly, a little bit of doesn't hurt anyone.
So how are you? How's this fine hump day treating you? How's everything going in the shop?
You know what? Everything is just peachy on my end. Things are great in the shop. We actually just purchased our very first CNC machine. It's a Haas vertical mill. I've never actually programmed a CNC before, but I know it's got to require some sort of CAM software. We're in the process right now of getting the machine all set up and calibrated, and next on the list, I would assume, is CAM software. So we're going to try to dive right into that, and as you guys say, letting the chips fly. To be perfectly honest with you, I have no idea where to start, so hopefully you can help me out on that.
Yeah, 100%. That's so congratulations on the first CNC machine. It's a huge deal and it's an exciting time in a shop. So when we're talking about CAM software or computer aided manufacturing software, there's a lot out there in the market. So I totally agree with you. It leaves the user not really knowing what's up and what's down. I got to say though, I know you're a longtime SOLIDWORKS user, and I need to ask, did you know that there is a free CAM software that comes embedded in all SOLIDWORKS seats that are either on term licenses or perpetual licenses on active subscription?
You know, that sounds familiar. I'm sure I've seen some emails about that CAM add-in in the past, but it wasn't applicable at the time for us, so I probably skimmed by it or deleted the email. You're telling me we currently have access to CAM software that we could use to program our Haas?
Yep, yeah, 100%. So back in 2018, SOLIDWORKS partnered with CAMWorks, and they came out with a version of software developed by CAMWorks that is fully embedded, so totally integrated inside of SOLIDWORKS. Yeah, so not only do you have access to this free software, but you have access to an extremely powerful, modern, feature-based CAM solution. And CAMWorks have been a gold level solution partner of SOLIDWORKS for over 20 years. So that software is coming from a trusted and well-developed place.
Well, that's fantastic news. I'm assuming SOLIDWORKS CAM is built right into SOLIDWORKS. Forgive me for not knowing already, but how do we access it?
Yeah, no, let me show you, because for first-time users who have never used it before, there are a couple steps that you have to do to get the add-in working. So I will share my screen with you guys right now, and we'll jump inside SOLIDWORKS. So we just have a new part file up, and the first thing that we want to do is we want to turn on the SOLIDWORKS add-in. So from the gear icon on the top toolbar, there's a little drop-down arrow. So if we select that, we can select our add-ins. That's going to open up our add-ins manager. And we're going to find the SOLIDWORKS CAM add-in under our SOLIDWORKS add-ins, so in that middle section. And if we click on the left, then we're going to activate SOLIDWORKS CAM for our current session. And if we click on the right, we're actually going to be activating SOLIDWORKS CAM every time we initiate and start up SOLIDWORKS. So once I press this OK button, the add-in is going to take a couple seconds and then it's going to load itself. And we're going to know that the add-in is fully loaded because we're going to see a couple areas inside of SOLIDWORKS change. So the first area is the command manager. So we're actually going to see two new tabs appear. We've got our SOLIDWORKS CAM tab, and then we've got our SOLIDWORKS CAM tolerance-based machining tab. So just a quick note, we do have a tolerance-based machining module that comes with the standard version, and we can essentially read the PMI or MBD data on our modeled part, and we can program it accordingly, keeping in mind GD&T information and part tolerances, etc. And from the feature manager, if we check out on the left-hand side here, we have 3 additional tabs that show up when we have the add-in loaded. So we're going to see our CAMWorks feature tree, our operations tree, and our tools tree as well. Now, you might come across a situation where you see the add-in, you activate it, but nothing appears on the screen. So you don't see the command manager tabs, you don't see these tabs in the feature manager. Now, sometimes what happens with SOLIDWORKS CAM is you need to reactivate the CAM module. It's really easy to do so. If we're talking about a standalone license, the way that you would do that is from the top right area in your SOLIDWORKS application, you want to make sure that you click that help button, and you're just going to go down to licenses, and you're going to select activate. Now, this is going to open up our product activation wizard, and here I can see on my screen SOLIDWORKS CAM. You may or may not, sometimes you don't see the SOLIDWORKS CAM add-in, but you simply will select all, and then you'll press next, and that's going to go through the product activation wizard, and you'll have a final screen that's going to show you if you've successfully activated. So that's kind of the first hack. If you don't see the tabs appear and you can't actually use the add-in, you might need to reactivate. Now, when we're talking about a network license, it's a slightly different procedure. So there's actually 4 steps. Now, we want to make sure that we reactivate our SOLIDWORKS license from the server computer. So we're going to be actually in step 1, opening up this solid network license manager. From the server administration tab, we want to make sure that we modify our license information. That's going to bring us to this next window where we can activate and reactivate our product licenses. The third step, you'll see the serial number on the server computer, 1 or more, however many serial numbers you have, and you'll simply select the serial number 1 or more that you want, select all in this case, and click next. And then you're going to enter that final screen, which is the activation, reactivation, and it shows you if you were successful or not. So next scenario to touch on briefly, if we don't see the SOLIDWORKS add-in at all. So we go to our add-in manager, we open it up, but we don't see SOLIDWORKS CAM, it's not appearing. That means when we installed SOLIDWORKS, we might not have installed the CAM module. So what we can do in that case is we can actually go to our control panel. We're going to open up our control panel and we're going to select from programs to uninstall a program. So then what we would do is we would actually scroll down, we would find our SOLIDWORKS instance that we wanted to, in this case, modify, not actually uninstall. And we would just select that and then check to change the installation. So once we go to change this installation, it's going to open up our SOLIDWORKS installation manager. And this is where we're going to simply choose to modify our installation. Now, I'm not going to press next because I have some sensitive serial numbers on the next screen, but I do have a screenshot for you guys to show you. This is what it's going to look like when you press next. So you're going to see the additional SOLIDWORKS modules that you could download or install on your computer, like visualization, simulation. In this case, we would want to select the CAM box. So we'd make sure that we had that check mark beside SOLIDWORKS CAM. If we're talking about SOLIDWORKS CAM Professional, then we'd have a serial number we'd have to input. But for the standard, it's tied to your SOLIDWORKS serial number. So you wouldn't have to input any serial number. And all you would have to do is click next to install that additional component. So Connor, does that all make sense? Does that seem clear?
Nice. Yeah, it seems pretty convenient that we already have a CAM solution. My God, my boss is going to really like this.
I think he will. I think he will.
Yeah. So what other types of machines can you use CAM standard to program?
A variety of machines. So from 3-axis vertical and horizontal milling machines, also routers, so gantry type routers that are 3-axis. We also have considerations for plasma, laser, and water jet machines too. So standard has a capability to work with all these different types of machines.
That's amazing. I mean, there's already talks of us getting a CNC lathe for our next machine. And who knows, possibly down the line, 4th, 5th axis machine. Would standard be able to cover that kind of increased functionality?
So when we're talking about lathes or a 4th or 5th axis, whether that's indexing or simultaneous, then we're actually moving up away from standard and we're moving into either SOLIDWORKS CAM Professional, the next package up, or one of the many available CAMWorks bundles. So it really depends on the individual machine kinematics. And of course, you could discuss that with your reseller and find out, well, what bundle is going to be best suited for your machine functionality.
Yeah, and how about we explore some of the different options there with SOLIDWORKS CAM and CAMWorks? Take a
Yes,
look at the slides here.
do
This
that.
outlines the CAM packages available with SOLIDWORKS CAM and CAMWorks. You'll see SOLIDWORKS solutions are bracketed in the red and CAMWorks in the blue. This is just a basic overview of the key features in each package. All the functionality included in a lower package carries over to the next package up. So to explain on that, SOLIDWORKS CAM has the functionality, SOLIDWORKS CAM Professional has the functionality of CAM Standard plus more. When looking at CAM Standard, you'll see features like the 2.5 axis milling for your basic CNC parts, and like we were discussing before, the intelligent machining practices, tolerance-based machining, automatic feature recognition, and knowledge-based machining, all of which, Kirsten, we're going to have you define and go over, kind of show off later today. One of those key features I'd actually like to point out is the CAMWorks NC editor. And correct me if I'm wrong on any of this, Kirsten, but it would allow you to program, take a look at that program and edit the lines of the G code individually to adjust the program. Is that correct?
Exactly. That NC editor powered by Simco is going to allow you to not only adjust your G code using a lot of really simple, easy to use commands, but it's going to allow you to backplot as well. So you can visually see any changes you make to the code.
And so that's included in every SOLIDWORKS CAM package as well as the CAMWorks packages, correct?
Correct. Yeah.
Okay. So when determining which package is perfect for your application, we're going to need to go through with your SOLIDWORKS account manager or with Kirsten based on what machine you currently have, and then the specific types of parts you're manufacturing in order to make a recommendation on the perfect package for your needs. So Kirsten, you mentioned before, CAMWorks is a feature-based CAM software, but what exactly does that mean?
Great question. So it means that while programming inside of CAMWorks or SOLIDWORKS CAM, the workflow consists of first defining the machinable feature, and then we're going to add tool paths or operations to that feature.
Okay, so does that increase the amount of time it takes to program?
Not at all. In fact, it's actually going to significantly reduce the amount of time with programming. So CAMWorks has this super powerful tool called automatic feature recognition, and it uses FeatureWorks technology to scan your 3D model and almost instantly extract over 20 different types of 2.5 axis machinable features.
So essentially it's scanning my SOLIDWORKS feature tree?
Not quite. Actually, the technology is analyzing the geometric model itself. So this means that it works just as efficiently with imported models as it does with native SOLIDWORKS models. How about we jump into CAMWorks and I can show you a little bit of what I'm talking about?
Sounds good.
Okay. So now we're back into SOLIDWORKS. And you can see here, I'm inside of a CAMWorks module. So the branding is a little different. Instead of SOLIDWORKS CAM, I can see CAMWorks on my command manager and CAMWorks inside of my feature manager. But the core functionality is the exact same. So we've got a part here. It's a very feature-rich part, I would say. There's a lot going on. And now if I were to, let's say, talk about a lot of the CNC CAM options out there, programming software, I'm going to have to make some considerations before I start programming this part. It's going to involve me taking a bunch of measurements of the part, kind of trying to get in there and digest what are all these different features and how am I going to go about machining them? How do I want to define them? So when we're talking about operation-based CAM systems, we still have to define through faces or lines or sketches the areas which make up our toolpath. So I want to make sure I know if there's any tapers on these walls, if there's any constant radius fillets in the corners or on the bottoms or tops. And also I'm going to have to spend some time to consider what tools do I want to use to machine the different features that we see on this part. So in CAMWorks, we have this automatic feature recognition, and it works in the form of this extract machinable features button that's found in the top left on our CAMWorks command manager. So when I actually click this button, we're going to initiate that AFR, and CAMWorks is going to start scanning our solid model, and it's going to intelligently define these features for us. So now we're still in our CAMWorks feature tree, and we have a population. So it's found our mill part setup, that 2-axis plane that all of our tool movement is going to be based off of. This is really nice if we had features on, let's say, the sides of this part or the bottom of this part. It would find all the applicable mill part setups for us with simply clicking that extract machinable features button. So that's something I really like about the software, because I might not be paying attention to, hey, are there any features on the bottom? Or maybe I missed the back face and I don't know that there's a hole or a pocket there. But if you can see on the left-hand side, it's found a lot of features for this mill part setup one. So we've got a face feature. It's found a perimeter boss feature. Let's say we want to contour out this the perimeter of this part. We've got an open pocket. And I get a nice visualization in my graphics area of what exactly is the definition of that feature with these green, solid, and dashed lines. So these dashed lines here are actually representing my open air edges of this open pocket. We've got a regular pocket, some rectangular pockets, a bunch of more regular, rectangular, and some circular pockets down here as well. So it's found quite a bit of information, but it hasn't just identified the feature. It's gone further. It's identified the geometric conditions that make up those features. So for example, our open pocket one, if I right click and select parameters, I'm going to get a bunch of information about this actual feature. So I can see here its depth is 40 millimeters. It has one island identified. We can see here the overall length and width of the feature itself. So that's really helpful stuff. It's not simply calling out a feature for us, but it's giving us a lot of information on what actually defines that feature. Let's check out this irregular pocket one. So once again, I see my depth and my length and my width, but I can also see here my finish radius. So it's going to calculate the smallest finish radius in any of these corners inside of this feature, and that's going to let me know and help me define what tool do I need to apply for, let's say, a finishing toolpath or even a roughing toolpath if I only want to stick with my roughing. Another thing to point out too is that I have access to this taper information. So if there's any taper information there, I'm going to know immediately. Now these features can also be further edited if needed, most of them. So I could, for example, let's go down to one of our rectangular or irregular pockets here. I could double click that feature. Now it's going to open it up and I can go ahead and edit the feature. So I not only have control over the actual sketch, face, or edges that define that feature. Let's say if I wanted to tweak those slightly, I can also change my end condition. So right now the feature has been defined as a depth of 15 millimeters. based on the top face that defines that feature. So I could pretty easily override this. I could make this shorter or taller if I needed to. I could also go ahead and I could manually add in some taper information if I wanted to. So I could go and manually add in a positive draft. Another really cool function is move. So the feature exists right now on our model as it was analyzed, but I could actually translate this feature slightly. So I could change the X, Y, and Z coordinates and move it to whatever location I needed it to. I needed to move it to. And then of course I can reset to 0. So it's finding the features for us. It's giving us a wealth of information about what makes up that feature, but still allowing us further capability to tweak it as we need to. So what did you think of that, Connor?
Well, I mean, thanks for showing me. It seems like a pretty incredible tool, especially for somebody who's a first-time programmer like myself. So the next steps in programming would be to create toolpaths based on the features listed. Is that correct?
Yeah, exactly. So yeah, we've defined the features. Next, we want to add some toolpaths. But with CAMWorks, that process is also automated as well. So one of the best features of CAMWorks, and this of course comes included with SOLIDWORKS CAM, is what's known as intelligence-based machining. What does that mean exactly? Well, CAMWorks has a technology database running in the background. Now, this TechDB, as it's known, stores a lot of information, including toolpath machining strategies. So strategies could be defined as a sequence of one or more operations or toolpaths that we would want to apply to a particular machinable feature. We can use this command inside the software to automatically generate an operation plan or sequence of toolpaths for, let's say, one, multiple, or all of our machinable features. CAMWorks is going to scan the database that's running in the background, and it's going to apply our default strategies that we've chosen based on feature conditions. So things like I showed you, like the depth of feature, the width of feature, even things like the stock material or the spindle attribute. Is it a main or a sub spindle? And it's going to scan these feature conditions, and then it's going to apply the toolpaths accordingly.
Wow. So you're telling me all I have to do is click one button and I can essentially instantly program my parts?
Yeah, I know. It's cool. And pretty much, yeah. CAMWorks is also going to assign tools to individual toolpaths based on intelligent rules that we tell it to abide by. Furthermore, it can apply specific operation parameters or toolpath settings to each machinable feature. So we can have the software automatically define things like depth of cut, our roughing strategy, what kind of lead in, lead out do we want to apply? Stuff like NC parameters. So we can set our clearance plane, our feed plane, and all of this with the click of a button. So there's no need to change these settings over and over as you program each new part. You can really teach the software how you want to use it as you use it by saving back all of your changes to the technology database.
Now, not that I don't believe you, Carson, but it all sounds a little too good to be true. Would you be able to show it off, or let's check it out?
Yeah, 100%. Let's check it out. Okay, so hopefully you can all see my screen, and we're back inside SOLIDWORKS, inside CAMWorks. And yeah, so the next thing is to point out to you guys, so we're still in that CAMWorks feature tree, and we've got these brackets beside each of those features that have been found. So we've got our face feature with a bracket that says finish, that perimeter boss, finish. Some of these irregular pockets and rectangular pockets have a rough rest finish strategy. So this is defining those sequence of toolpaths. Now, I can go in and I can tweak an individual toolpath strategy if I need to. So let's say in this case, I don't like the default one that was defined. I still have that ability to like open up the actual parameters of the toolpath, or sorry, of the machinable feature. We have this strategy drop-down window. So right now, if I hover over, I can see that rough rest. That middle roughing toolpath, by the way, is the rest machining. So it's going to come in with a smaller tool and it's going to clean up any rest areas or remaining material that remain from the previous roughing operation. But maybe I don't want to machine this feature that way. I can easily select an alternative strategy available, and I can save an infinite amount of strategies. So it's totally customizable. I can name them whatever I want. And as long as that toolpath is applicable for that type of feature, I can add it in. So I can easily select a new strategy manually on a feature by feature basis. But I also have this nifty button in my command manager called default feature strategies. So I could also change the strategies as they apply to all of the feature types that are found inside of that mill part setup. So if you see here, we've got some brackets beside the list of features. So those 4 rectangular pockets, if I wanted to change the strategy, all I would have to do is select from the list the alternative strategy. And then once I apply that strategy by hitting this apply button at the bottom, it's going to update them in my tree. So I can do it on a feature by feature basis, or I can do it communally through the default feature strategies. Another important thing to note, so this is actually the default feature strategy scheme assigned to my current machine. So if you see on the left-hand side, I've got my Haas VF3 loaded right now. But if I selected to edit or view a strategy scheme from, say, our technology database, I could then view all of the different schemes that I've saved. So we have the ability to save a scheme to an individual machine, but we still have infinite space to save additional schemes. And we can load those and use them as we need to. We can set those for different types of material, different types of machines, different types of tolerances, etc. So there's so much room for customization there. And I can actually even tweak the default strategies as I see them here and save a new scheme, save as inside of my current document, and save that information back to my TechDB. So once I kind of have the strategies as I want them, the next step is to go ahead and to generate that operation plan. So when I click this button, this is when CAMWorks is going to scan that technology database. It's going to consider all the features and the geometric conditions that make up those features, and it's going to apply those toolpaths accordingly. Now, for the first time, we've actually jumped over into our CAMWorks operation tree. So we see a bunch of different toolpaths, but they're ungenerated. So they haven't actually been generated into toolpaths yet. That last button there is going to do that for me. Now, once I generate those toolpaths, I can simply click or hover over them in my screen, and I can see a visual of the toolpaths themselves. We've got this tooltip information in the top left corner of the graphics area. Just bring this in a little bit. So we can see a bunch of information about the actual toolpath itself, and we get that nice visual of the different toolpaths. And of course, all of the color schemes in SOLIDWORKS CAM and CAMWorks are customizable, so we can control how things are viewed inside of our graphics area. But with a couple clicks of buttons, that's a lot of toolpath to have generated. And I did it intelligently based on my shop's best machining practices. Now I could easily sort these toolpaths. So we probably don't want to post out in this order. So I could right click and then select to sort those operations. And of course I can sort by setup or across setups, and by and across if I had multiple mill part setups here. And the second tab at the top, sort, is going to allow me to choose, do I want to sort by operation type or tool? So we'll keep it on operation type. And then I can do a secondary sort by, let's say, tool. And I can simply drag and drop these items, and I can customize my sorting scheme exactly how I want it. Same for the tools as well. And I can load additional schemes. So once again, I can apply kind of infinite customization in every step of my programming process. So once I have my sorting operations, I'll just click apply at the bottom. And then it's going to sort it based on, like I advised it, strategy and then tool. And one other thing I wanted to show you as well, if I expand any of these toolpaths, I can see the feature that they belong to. So that's a nice thing as well to have on hand, is to know, okay, this toolpath belongs to this feature. And of course I can sort them based on feature as well. So I could keep a certain order, like roughing and then contour, and keep that per feature. So kind of complete one feature, move on to the next, complete the next, etc. So in a few clicks, we found our features, we generated our operation plans, we pulled all that information from the TechDB, and we generated our toolpaths. Now, what happens if I need to make a design change? What happens to those toolpaths and all that information as it's been generated? So let me just jump over back into the design tree and let's check that out. So I can go ahead and I can make some changes to my features themselves. So let's increase that base extrude. Let's decrease this cut extrude. Say 35 millimeters. Let's make a change to one of our sketches. Because this is the reality, is that, you know, when we're in the R&D phase, things change over and over and over again. And do we want to go and reprogram that part every time? Certainly not. So because everything is integrated inside SOLIDWORKS, there is that connectivity that is never lost. So if I go and jump back into my operations tree, CAMWorks is going to let me know, hey, the data needs to be updated. Toolpath features have changed. It'll give me an idea of what toolpaths need to get updated, and I can just click OK. Now it's going to take a couple seconds. It's going to do its thing, but it's going to regenerate my toolpaths as I need them to be. And that's just going to save me a lot of time and prevent me from having to reprogram this part. So we can go and check out some of those toolpaths, and we can see that they now exist as per the model geometry, and everything is in sync once again. We'll find our part perimeter in here. You can see that's also updated appropriately as well. I'll just drag that to the bottom because I want that to be at the end. So I hope I proved to you, Connor, that it is kind of that simple. We can click a couple buttons and program our part rather instantly.
It really does seem pretty easy there, but I do have a question for you there. So I program my part, I have my part file, I've got my G code generated. I know my operator on some projects is going to come back to me with changes that need to be made. So
yes,
how can that operator take a look at my toolpaths without having to come into the office and jump on my computer every time to see them?
Yeah, that's a tricky one. So typically machine shop floor personnel are really limited in what CAM and CAD data that they have access to at the machine. Like you said, you generate that G code file. So they have a file of code, but that doesn't really show them what they're cutting or how they're cutting it. And more often than not, these operators are just opening up this code in a simple document reader. So Notepad, maybe Microsoft Word, and if they've got to make any changes, they can't necessarily see those changes reflect. So they're going to have to come back into the office, and they're going to have to tap you on the shoulder and maybe check out some simulations. You know, you could generate setup sheets for them. So that's a functionality in SOLIDWORKS CAM and CAMWorks, and the setup sheets are great. They can accompany your G code file, and they're static documents, but they'll help the operator know information about how to set up the stock or the machine, the controller. It'll give basic estimating time, part material, and so forth. But they're pretty limited otherwise in the CAM and CAD data that they can see.
Okay, I think I'm following there, and I'm sure that documentation would definitely be useful in the process, but my operator can see the code and the basic information relating to how that part needs to be set up, but they can't see a visual play-by-play of the toolpath simulating. I think that's pretty critical for the operators to see before they run the program, don't you think?
Yeah, 100%. It's definitely beneficial, especially when we're talking about complex machining operations, like fourth and fifth axis indexing, and of course, fourth and fifth simultaneous machining. Working personally as a CNC operator in the past, there were so many times where I found myself cutting complex parts, what we call blind. So I had my hand on the feed knob, just like kind of standing there at the machine, really hoping that I could prevent any kind of crash if it were going to happen, but not. The point is not really knowing what was going to happen. So when machine operators have access to toolpath simulation and step through data, they can run those programs with a lot more confidence. They can also anticipate problems or errors that the programmer might not have even considered or picked up on. So have you heard of CAMWorks Shop, the CAMWorks Shop Floor application by any chance?
No, I haven't. What is it exactly?
It was introduced back in 2019 to the CAMWorks suite of software products. It's this really neat collaboration tool between CAM programmers and CNC operators on the shop floor. And it allows the operators to view the CAD model. So that's an individual part file or even an assembly of parts, and the CAM data that are associated to that model. So before, as I said, this was really only possible if the shop floor operator went into the programming office, or if they had, let's say, SOLIDWORKS or CAMWorks Solid, which is CAMWorks CAD modeling tool, and CAMWorks installed on their computer. If they had all that software installed on their computer, then they could view the toolpath data. But as you can imagine, that's a pretty pricey workaround to allow for operators to view CAD and CAM data dynamically at the machine. But this CAMWorks shop floor is, it's simple, but it's an incredibly powerful and handy tool, and really cost effective to kind of overcome that and let the operator get a good visualization of what they're going to cut or about to cut.
Mm-hmm.
Did you want to see it?
Yeah, so would we be able to take a look?
Of course. Let's check it out. So here I am. I have programmed my part. Because I'm showing you shop floor, we're not going to simulate it inside of CAMWorks. We're going to simulate it inside of shop floor. We're even going to post it to shop floor. So there is, from the CAMWorks command manager at the top, there is this publish shop floor button. Now this is known as the shop floor publisher, and this is going to allow me to publish a file, a shop floor file that we can then open up in the application. Theoretically, I'll be opening it up on my computer, but theoretically it would be sent, it would be shared. If those two computers, Windows computers, were connected via a network, it would be put in a shared location between those computers, and then the operator could just pick it up from that shared location and open it up in their version of shop floor. So we can see here, we've got the publisher open. I have the option to output my G code with my shop floor file. So yes, I want to do that. I'm going to click that. If I needed to, I could change the post processor from this window. I could also output setup sheets. And new to 2021, CAMWorks Shop Floor 2021, we have the ability to add additional references, additional documents or references. So this could be anything from a SolidWorks part file, a reference file, a SolidWorks drawing, let's say a work order for the CNC operator, images that we wanted to send along. And what we could do is we could add in these additional references. We would simply search for them on our shared location if we wanted to include as a reference, or we could add as a copy. And those documents then would travel essentially with the shop floor file, so that our operator would kind of have instant access to them. So it's going to eliminate a lot of that paper clutter at the machine, and it's going to seamlessly allow you to kind of send everything you need out in one shot. So for now, I'm just going to output my G code, and I'm going to go ahead and I'm going to publish this file. And of course, I have control over where I want to publish it. By default, it's going to publish in the location where the file was saved. So in this case, I have it on my desktop. I'm going to see a message from CAMWorks that it's been successfully created. And now we're going to go ahead and open it up. So as I mentioned, this next step would be performed by the operator at the machine. So they'd have the application installed on their computer and they would be opening it up. So it's going to import a bunch of information for us. So the very first thing is I have a full dynamic view of the assembly or the individual part file that I'm machining. So I can see the CAD data. I have access to that CAD data instantly. From these top tabs here, so I've got the view tab, I have a lot of different ways in which I can view this CAD model. And you can see there's a lot of familiarity if you're working in SOLIDWORKS a lot. You see the similar view commands. We have a bunch of render modes that we can choose from. In the middle here, we have a lot of navigation tools. So rotate, pan, zoom, zoom to fit. And we have control over component visibility in this last area on the right. So we can tweak this model to make it easier for us to interact with and to view. Next on the tabs, we have measure. So we can control how do we want to measure. We can filter by points, edges, or faces. We have a bunch of linear measurement tools. We can measure the length of an edge. We've got our radial measurement tools in the center here. So the radius, diameter, 3-point circle. Angular measurement tools. We can also measure the area of a face. So a wide range of available tools for you. Inside of the actual tools tab, we can go ahead and dynamically section our part if we needed to, and we can select the plane that we wanted to create that section along. So here we have the XY plane. We could go ahead and turn on the YZ plane, section that part as we needed to see any internal features and maybe gather a little bit more information about what it is we're about to machine. So really helpful. The next tab over, CAMWorks tab. So this is where we can actually simulate, step through as well, and view our G-code and or setup sheets if we had posted any out. So let's go ahead and simulate. We can simulate globally from the top, or we could actually right-click an individual operation and we could simulate the individual operation. So we're going to go ahead and we're going to globally simulate those toolpaths. Now it's going to open up my Simulate Toolpath Manager, and I can go ahead and I can choose between tool mode. So I'm going to see the tool as it cuts all of the features, each individual tool, or I could choose turbo mode. So turbo mode is going to cycle through my toolpaths as quick as possible to get me to that final result. So we'll stick with tool mode, and just to show you, we can choose a bunch of different end locations for this simulation. So next Z level toolpath or operation, next tool change, or simply the end of the program if we wanted to. So let's press play and we can start simulating. Now we have a bunch of display options as well. So you probably noticed we have this speed bar here, so we can speed things up or slow them down as we need to. In terms of display, I have control over how I want my stock to display, translucent, wireframe, solid with edges. I have control over how I want my tool to display itself, if I want to show my tool holder or not, and even my target part as well. How do I want my target part displayed inside the simulation? I have collision options. So I can choose to turn on collision options for the cutting portion of my tool, the non-cutting portion, even my tool holder. And I can tell the software, what do I want it to do if it detects a collision? Do I want it to ignore it and keep cutting? Do I want it to stop on that collision? Or do I want to have it cut the collision, but show me when I go and compare results between my machined and modeled part? So that display difference option at the end. There are additional simulation options as well. So we can choose quality over speed or speed over quality, tolerance ranges, etc. We even can save out WIP, so work in process, kind of snapshots of our model as an STL file. We could save out WIP files as a JPEG if we wanted to include in like a setup sheet. And another thing I really love about the CAMWorks simulation tool is we get this information at the bottom that shows us what operation we're on and what tool we're currently using to cut with. I can even click this XYZ button, and this is going to open up my coordinates for me. So I can see all of my linear, circular, arc moves, my rapid moves. And of course, if I slow down this toolpath, then I would get a better reading of what's happening when. So we'll just speed it up a little bit. I don't want you guys to be watching this simulation for too long, but essentially at the end when this is done, that's when we're going to display difference, and we're going to check out how our machined part compares to our model. And are there any overcut or are there any undercut areas that we need to be aware of? And we can see on the left-hand side kind of as we cycle through those different tool paths as well. And we'll just give it a couple more seconds. And now we'll go ahead and we'll show difference. And we've got this tolerance box in the top right or top left corner rather of our graphics area. And that's going to show us based on these tolerance ranges, have we cut our part to spec? Are there any undercut areas that are going to appear in blue, or are there any overcut areas or gouges indicated by red or warm colors? So as I mentioned, we can simulate those toolpaths, but we can also step through, and that's globally or per toolpath as needed, and lots of functionality within the step through as well. So we can choose that end condition. Where do we want to step through to? We can go step by step if we wanted to and see our toolpath traces, or we can simply choose to play through. I'll probably adjust the speed a little bit for you because it's going to go pretty fast. But we're going to be able to see our toolpath as we step through that program. Here we've got our information, our move types, and from what position to what position is each line of toolpath creating. And we can also see some additional stuff at the bottom, like our feed rate, our spindle RPM, and our operation and our tool information. So, and also different display options in here too. G-code. So before I show you G-code, actually, I wanted to show you a couple other things. Inside of our tools tab, we have all the tools that are currently loaded in the tool crib. And we've got the tools appearing in black that are active in this program. We can expand those and we can check out what operations they belong to. And here's that documents manager. So if our programmer sends along any additional documents, they would appear here. We've got our part and assembly or assembly file and our G-code and setup sheet as well. Another thing to note, we can view annotation. So we can search for and filter by the PMI data on our model or the MBD data on our model. So we can see part tolerances, linear tolerances, asymmetric, symmetric, GD and T information. So this is really critical for smart manufacturing. We want our operator to know if we've got specific part tolerances on our model that they need to abide by when this part is machined. And lastly, we can open up the G-code. So as Connor pointed out earlier, we have that NC editor powered by Simco. So it's also included in the CAMWorks shop floor module. And it's going to open up initially as a read-only document, but we can, of course, save as and create a document that we could edit at the machine. We have a bunch of different editor tools and NC functions, so renumbering, removing lines, changing uppercase or lowercase, adjusting feed rate and spindle speed, lots of different stuff in here to make those changes kind of systematically and more intelligently. And then of course at the end, so if we needed to make any changes, we don't need to go back to the CAM programmer. We can actually, if we feel comfortable, we can edit the code ourselves at the machine. And then if we needed to, we could go ahead and backplot it. So we could actually check out our code line by line and make sure that any changes that we made, we're totally aware of what the machine's going to do and any implications of those changes. Last thing to point out, the NC editor also has transmission options to set up DNC. So yeah, it's it's a simple tool, the CAMWorks shop floor module, but it's so necessary for making that CAD and CAM data visible rather from the design and programming office all the way to the shop floor. So I hope that you can see the value of that from my brief presentation, Connor.
Well, I mean, you certainly checked a lot of boxes today, and it seems like a way more powerful tool than I even thought. Personally, I have to thank you for your time today.
Pleasure.
I think the feature-based CAM tool that leverages CAD models is incredibly useful, especially for our application, not to mention the time saving with automatic feature recognition and intelligence-based machining. As a new programmer, this is going to allow me to utilize some of the best machining practices through the technical database. Also, shop floor seems like a perfect way for us to push into that smart manufacturing and in industry 4.0 technologies that my boss is always bugging me about. So I can't wait to dive a little bit deeper on this with you and get the ball rolling.
Excellent.
All right. So we have a couple minutes here before the end of the hour. I'd like to invite our marketing director, Jessica Roberts, on to help us with some of the questions that have come in over the hour here. So Jess, would you be able to just run through a couple of those with us here?
Absolutely. Thanks very much for the presentation, guys. So we do have a few minutes left for some questions. We've got a few in the queue already, but if you haven't got your question in just yet, you can still go ahead and throw that into the questions box for us. The first question that we do have in the queue here, Kirsten, I think this one is best directed at you. The question is CAMWorks shop floor available for use with SOLIDWORKS CAM?
Yes, it is. It's fully compatible with SOLIDWORKS CAM, whether it's standard or professional. So I don't know if you guys remember when I published the shop floor document, I just clicked that publish to shop floor button. So all that's really required if you want to use shop floor with SOLIDWORKS CAM is to download that publisher as an add-in. So that comes free from CAMWorks. And then the actual shop floor module would be available for purchase through your reseller. And that's what you would set up on your operator's computer at the machine.
Perfect. Thank you, Kirsten. Connor, I think we'll throw this one your way. The question is, what would be the benefit of a user being on the support plan?
So not only does it give you support through technical support, being with Kirsten or one of our other experts, but it also gives you access to the latest minor and major software releases, but is crucial for you to want access for that SOLIDWORKS CAM add-in. So technical support as well as the releases, just like SOLIDWORKS, CAMWorks does the exact same thing with the service packs and releases to stay up to date as well.
Great, thank you, Connor. A question here on training, so I think we'll stick with you for the moment, Connor. Does CAD Micro offer training for CAMWorks and for SOLIDWORKS CAM?
Yes, so we have flexible, comprehensive training packages from our certified CAM instructors. If you're interested in training, the best thing to do would be reach out to whoever your account manager is, and you can receive a quote for pricing on the specific training package that would be applicable for the type of CAMWorks or SOLIDWORKS CAM that you are working with.
Awesome, thank you, Connor. Kirsten, we'll throw this one your way. Are there any other CAMWorks modules available that we haven't shown so far today?
Yes, there are a few. So if you've got a wire EDM machine, CAMWorks has an additional module just for wire EDM. So that's 2-axis and 4-axis EDM machines. And actually in 2021, they just released a professional version of the software, which significantly speeds up programming. We've also got a nesting module, so it's called NestingWorks, and this would work with CAMWorks and SOLIDWORKS CAM, but it's also compatible with other CAM systems as well. So important to note. We have an additive manufacturing module from CAMWorks for 3D printers. which will help you to mill the different supports that you have to kind of design and print and 3D printing. And we also have virtual machine simulation. So CAMWorks has this kind of inbuilt or external virtual machine simulator. And depending on the package level, whether you purchase standard, professional, or premium, you can simulate your cutter location data in a virtual machine environment, all the way up to simulating your true G code. So even further kind of collision detection support, and definitely within Industry 4.0 standards.
Awesome. All right, well, I think that is all questions answered, but as a reminder, if any questions come to mind later on, feel free to reach out to your account manager or reply to the email that you'll get from us tomorrow that will have today's recording in it. Likewise, if you're interested in seeing some numbers to crunch into or a personalized demonstration or have questions about which package may be right for your machine or application, feel free to get in touch. We'd be happy to put you in touch with some of our team members like Kirsten or Connor or others on the CAD Micro team. So thank you very much, Kirsten and Connor, for a great presentation, and thank you to all of our attendees for spending a little bit of your Wednesday here with us. We appreciate it, and we certainly hope to see you again soon. Thank you.
Take care.
Thanks a lot, everybody.